This will be a two-part workshop. The first part will be on creating a Solidity project using Foundry. So as EVM development is very tied to the blockchain, it's not as easy as setting up a Python project or other type of coding projects. So there is a tool which is called Foundry. So the first part will be to install this tool. So you can go to this website, getfoundry.sh, and install the tool. So you can go to docs.xrplcommons.org, same website as yesterday. The Git book has been updated, so this is nice. And you have a whole documentation on how to set up a Foundry project. So please follow this. This is a tool that allows you to start development on the EVM. So this is a tool based on Rust, and inside this tool you have, it's a bundle of tools. So you have 4 tools in it: Forge, Cast, Anvil, and Chisel. The only one that we will be using today will be Forge. So Forge is a CLI that allows you to create, to compile smart contracts, deploy those, and so on. So it abstracts a lot of difficulties inheriting from smart contract programming. So let's go to this website, install it. If you have any question, please raise your hands. I think we can have, let's say, 50 minutes just to install the tool, and then we'll get into the smart contract development. I recommend personally to use the curl. Don't build it from source, otherwise you will need to compile from Rust, and compiling Rust takes a lot of times. So just use the curl stuff to install Foundry up, and then just run the command that you have there, and you should be good to go. And in the end, you should have, when you run forge -- version, you should have something similar to this. Yeah. So if you have any question, please raise your hands. We'll have 15 minutes for this. Who there has a Windows machine without Linux subkernel? Okay. So for those who have only a Windows operating system, I think the easiest way to install it is through Docker. So if you go to the Forge website, there, and inside guides, installation, you can build it with Docker. It's only support Unix-like system, so the easiest way is to use Docker. Otherwise, you can install Windows subkernel Linux. Soit installe Docker, soit installe WSL. Moi, je te conseillerais d'installer WSL parce que c'est plus simple. So everybody has Foundry set up? Yes? Who doesn't have it set up? Okay. So if you have Foundry set up, who has run the command forge init to init a project? Okay. So the people who have run that, then you should have an issue with the latest stuff, which is Soldier. So to have some context, Soldier is a package manager. So before Foundry, it was a toolkit called RDAT, and basically it was using npm as package manager, but it's a JavaScript package manager, which is not optimal for Solidity stuffs. So there is this new package manager called Soldier, and you can access it through soldier.xyz, and you will be on this page. And then you can just look up for like Open Zeppelin, and here you will have the command to install it. So there is a typo in the doc. The way you specify the version is with a tile and then the stuff. So it's soldier.xyz, and then you can search the package there. If you have an RPC issue, just go to chainlist.org. This is a website that aggregates all the EVM stuffs. And just type in XRPL and ensure that you click the include testnet checkbox. And then you should see XRPL Sidechain testnet, so which have this chain ID, and the RPC, you can find it there. Yeah, so the the EVM and RPC setting on the docs is the one for the mainnet. We won't be using the mainnet today, so just ensure that you use the one on the testnet there. And when your MetaMask is set up, please go to tryxrplevm.com. This will be the faucet, so you can claim testnet XRP and get starting to deploy smart contracts and interacting with the chain. So you will need a GitHub account to access it. If you don't have any GitHub account, please come see me and I will send it for you. To get your address, if you are on MetaMask, just copy paste it from there. And then you will be able to paste it here and click on claim, and this will send you some tokens. When you have everything set up, you should be good to go to deploy your first smart contract. Yeah. So let me just go into. Okay, so I will just create a small directory. Okay, so if you have set up your small Foundry, you should have basically this. So you have multiple folders. The first one and the most important one is the source folder. This is where you will have your smart contract. So this smart contract is a very simple smart contract. It's basically just a number that you can increment and get the value of. And as I said, this is very close to object programming, oriented object programming, in a way that basically if you replace contract by class, you have something that is very similar to a class. So this is very similar. So here you have basically two functions and one member of the contract. So the member is number. So this is just a public uint 256. So public means that other contracts can access the state of this data. Yeah. C'est ça. Yeah. So the public keywords then means that basically this variable can be called from the whole blockchain. So this is a public variable. There is other variables such as internal. So internal, this variable will just be callable inside your smart contract. There is also private. So private means that is kind of function scoped. And you have external. External means that this variable is only callable from outside the smart contracts. Why does this matter? This matters because playing on this allows you to have better security. Even if this is public, like everybody will be able to see the value of it, the fact that you can scope it from public, external, internal, and private allows for better security. So it's not, if you put a variable private, everybody will be able to see what's the value of it, but nobody will be able to touch the value and modify this value. So this is the number, and then we have the function set numbers that take a new number and argument. This function is public, and then we just assign a number to new number. And then we have the increment function, that's also a public function that just increment number plus 1. The issue there, or not, it depends on what you want to do, is that because this function is public, everybody on the room can go on everybody contract and just increment the number and change the number. So that's something that you must have in mind, is that when there is public and you don't specify some custom logic on the function level, everybody can access it and everybody can call the function. So this is a small smart contract. We also there have some tests. I will just get very quick into that, but mostly you have this library that is imported, and then you define some tests. We don't really care about tests for today. And then you can also write scripts that's basically allow you to create stuff and like deploy it on the VM, but we'll be using the CLI for that. Yeah, and then we have this, which is the project setup, and a small README that we don't care about. So the next step will be to basically deploy the smart contract. So to do this, you will do forge create, and then you will pass the contracts that you want to do. So mine, I think, is, so the command will look like this mostly. Yeah. I mean, the command is not good. Like, I don't remember if there is like a dash or something. Maybe something like this. Yeah. So to construct this, we will go back to chain list, get the RPC URL we want to use. So we want to deploy this on the XRPL testnet. So we will get back there, paste the value, and then run it. Private key, we need a raw private key. To get the raw private key, what we will do is we will go on MetaMask. You will go there, click here, and then detail of the account, and then you will click there, private key, enter your password, and get the private key. So I'm just going to do that privately. Mostly for not seeing the password. I mean, you will see the private key later on the CLI, but. So you will have your private key that way, and then you can go back here and just paste the private key. So what this has done is basically it has just like dry run the deployment transaction. So it hasn't broadcast anything yet to the network. And to broadcast it, you just need to add the broadcast flag that way. And so this will then send the transaction to the blockchain, saying, OK, I deployed this smart contract with this bytecode, and then we have the details. So if you take the transaction hash and go to the block explorer, do we right now? So URL is explorer.testnet.xrplevm.org. And then if we just copy paste the transaction hash you have, you should see this, which is the detail of the transaction we sent to the network. And we have a success. So our smart contract have been deployed. And so it's precise there that we have deployed. So this address is my address, deployed this smart contract at this address. So as I said earlier on the presentation of the EVM, this address is basically where the smart contract live in the storage of the chain. And if you want to interact with it, you will need to define a smart contract with this address, its ABI, and we don't care about the state because we will query the state from the chain. And so this is our smart contract, great. So please just deploy your first smart contracts, and then we will get into the second activity, which will be around how to interact with a smart contract inside a web app. Okay. So we still have 35 minutes left. So we'll get into the next activities. We won't have the time to complete it, but at least you will see what it looks like to interact with an EVM chain. So to do that, please go to github.com and go to the training material 13 September. So if I can QR code that. So please go to this website and clone the repo. So this is the repo we will work on for the last 30 minutes. And basically this repository is a smart contract that allows you to have a very simple banking app where you can deposit some fund and people can borrow against it, and the front end that goes with it. Okay, so when you have cloned it, just cd into the stuff, and you should have something like this. So first thing is to install the package through npm, so just npm I at the root of the project. And we are good to go on the JavaScript side. If we open the project, we will see that we have basically this folder which is apps, and in apps we have contracts, cross-chain lending frontend that will be used later in this afternoon, lending frontend that we will be using this morning, and XRPL intro that we don't care. So let's just go into the contracts file and have a look at the smart contracts. So this is a very simple bank smart contract. The idea is that you, as the owner of the smart contract, can deposit fund into it, and people can get there and contract a loan against you. It's very simple. There is no interest rate, nothing there. So it's very, very simple. Don't put that in production. Don't put kernel fun in those smart contracts. And so the smart, basically, we have this address, which is the owner of the smart contract, a mapping, which is basically a map between an address and a uint256. This will track the balance. A mapping of the same type that will track the loan, and some events. What are events? Events are basically stuff that are triggered when there is some action on your smart contracts, and it mostly allows you to log some stuff on the chain. So you use events mostly when you want to index stuff. So let's say there is a transfer of value between two people. You want this to be indexed, and so you basically create an event to say, oh, there is a transfer of value between two people. So as in OOP, we have a constructor. So the constructor is only called when you deploy the smart contract. And the constructor there basically is just setting the public value of owner to MSG the sender. MSG the sender is the address that sends the transaction. So it could be either a wallet or a smart contract. And you have this modifier now, which is called onlyOwner, that will basically check if MSG the sender, which is the guy who sent the transaction, is the same value as this public variable owner. So this basically will allow you to have public functions that are only callable by onlyOwner. Otherwise, the function will revert with the message onlyOwner calculated in function. We have few functions. We have a deposit function, which is public, which is also payable. Payable means that you can attach value to it. So you can attach XRP to call this function, and onlyOwner can call this function. This function will increase the balance of MSG sender, which is in our case the owner, because only the owner can call the function, and emit a deposited event. So this is how you interact with the mapping. So you will call the mapping balance there with the key value and then increase the value there. So this will deposit fund into the bank. We have this function getBalance, which is public. Everybody calculates it, and a view. A view function means that it doesn't touch at the state of the contract, just allows you to read some data on chain, and this function will return a uint256. And basically, this is just a view inside the mapping of balance MSG the sender. You have then a function to loan. So to loan, you must have an amount superior to 0, and the balance of the owner should be superior or equal to the amount, which means that if there is 10 XRP in the bank, you can't come and ask for 12 XRP as there is not 12 XRP in the bank. And then you just increase the balance of the loan, decrease the balance of the owner, and just transfer the XRP to the people who have called the function. And then you emit an event, as basically if you want to put something in production, you want to index it because it's way cheaper to query a database than it is to query a blockchain. You will emit this event, and then you will have another service that will catch this event and store it in the database, so you have a storage in a very creable way rather than a blockchain. And then you have the repay loan function. This is used when you, as a borrower, want to repay your loan. Even if this case, like, you won't have any interest to repay the loan, as you don't have any interest, you didn't put any collateral, so it's just like free money if you get a loan. And then get loan amount, which is a view value function. And withdraw. So withdraw is the function that will allow the owner to withdraw the XRP on the smart contract. And so we check what's the withdrawal amount, so we get the balance of the owner. And then we transfer this to the owner, and we reinitialize the owner balance to 0. Otherwise, in the state of the smart contract, the owner will still have, let's say, 10 XRP in the bank account. And then we emit an event, and we have this function to get the balance of the bank, which is in fact the balance of the owner in the mapping that we have. So this is very, very simple smart contract, but it's mostly showcase you how those smart contracts in production might look like. Of course, here there is big gaps in the logic in how you handle the loan and stuff like this. But at least you get to see these primitives and these primitives, which are one of the most important primitives in Solidity. As I said, there is no token at the protocol level on EVM. So basically, your balance of, let's say, I don't know, Shiba Inu, which is an ERC20, is just a mapping, which is that. So there is no real token object. You will just update balance in a mapping. So the first step now is to basically compile these smart contracts. So I will just cd into there, and then just forge build. So I have some issue because I'm missing some dependency. So I will just do forge soldier install. And so this will install the different dependency that we need. So it's very similar to what we've made at the beginning with NPM, but we have done this for Solidity. And then when I watch for build, the smart contract is run. The compiler is saying me that I should use them import that way and not that way. I should wrap modifier logic to reduce code size and so on. And so that's why I take the time to make you install Forge. It's because it's the best tool to use when you are developing smart contracts. I know that you have this small track in 42 about blockchain and stuffs. So it is currently on the EVM. It's deploying an ERC20 and an ERC721. So if you just know how to use Forge, basically you will pass 30 minutes on that and you will get your points. Yeah, so we just built the smart contract, then we will need to deploy it to the chain. So forge create, and then it won't be this time counter. It will be the name of the smart contract we had, and so the name of the smart contract we have is simple bank. And so we have the transaction hash, and we will need to save this. So this is the address of the smart contract. So I will just write it there. Up. And if we go into the Forge project now, we will have this out folder, which is the result of the compilation of the smart contract. And inside the out folder, we will have this smart contract, which is simple.sol, which is the result of the compilation of the smart contract we just built and deployed. We can go there, open this file, and I will just copy paste this into a JSON prettifier. And so we have, in the end, this JSON file. So this JSON file is necessary and required to interact with the smart contract because it contains this. This is the ABI, and if you look at the ABI, it's a big JSON data. And this data basically describes your functions and what does the argument. So if we take, for example, so this is the events. We won't care about the event for the moment. If you take the function withdraw, you will see that it takes no input, it outputs nothing, and it's non-payable. And so this describes the function in a way that makes you able to call it from the outside world of the chain. You then also have the details of the event. So if you want to index event, you will use the ABI to get the different event that you need. And in reality, what you need is only the ABI of the function that you want to call. So if you have a smart contract, there is no function that you want to call, there is no need for the ABI because you won't interact with it. But if, let's say, there is the transfer function that you need to use for transferring a ERC20, you will need to just get the transfer part of the ABI. You won't need the full ABI. So we will take this also. So we'll take the ABI, and then we don't care about the bytecode. The bytecode is the data that is put it on chain. So your smart contract on chain looks like this. And this is basically the program that the EVM will take in input and run against. And so it looks like this. And then you have the source map, the deployed bytecode, and other information about your smart contract. But as a front-end developer, you will only care about this. So you can take the ABI, copy-paste it, and then let's go back to our app. So we have deployed the smart contract, we're good to go. We can now then cd into lending frontend and go into SRC. Inside SRC, we have a contracts folder. So this will just export this, which is the interface of the contract. So what I've made is that I imported the contract object from ethers. Ethers is the JavaScript library that allows you to interact with EVM chain. and I just extended that with the different function that I will call using the ABI that I have. And then there is an address there. We don't care about this address. This was the address I used when testing the stuff. I will just take the address I have just saved in my notes. And save this. So here, on this file, we have everything that we need to interact with the contract we just deployed. We have the address of the smart contract, the ABI, and an abstraction using Ether that will make the life more simple when interacting with it. We can now npm run dev this, and I don't know if it will work because the idea is that we work together to make this project work. So this is the front end. The front end is broken normally, like nothing is going on. And it's because the purpose of this workshop is basically to see how we develop with smart contracts. So this front-end code is based on React. So I'm not a big fan of it, but it was the legacy code that I have to work with. And for each step that is broken, you have a TSX file, which is the file broken, and you have a solution.txt. And so if we go there, basically, this is the Web3 context. So how does React work is that you have like this big shared folder, which is kind of like a big bin where you put everything of your application or the state of your front end. And then you will import and export stuff from it and then use it inside your components. As I said, I'm not a big fan of React, but that's what most of the companies use in the blockchain world. And so we basically need to create this const connect codec function, which is the function that will handle the connection to MetaMask. So the int is basically the solutions. So the first thing that we need to do is first get the provider. So what's the provider? The provider is the injection of the RPC, the chain ID, and so on that you've made on the blockchain engineering side with Foundry, but we need the same data from MetaMask. So this is what's happening there. We use ethers.browserprovider.ethereum, and so basically MetaMask inject through the Ethereum namespace the provider arguments. Then we need to ensure that we have on the good network. So we will call the await switch to XRPL network. So this function, which is defined there, is there. So what we are looking at is the network of the provider. So the network is identified through the chain ID. And then if the chain ID doesn't match the chain ID that we get on chain list, then we have to change to this provider. And then we need to get a signer. So what's the signer? The signer is basically an object that allows you to send a request to your wallet to sign a message. So it's the same, it's an abstraction around this concept of private key that you have on Forge, where the idea is that you need to have a private key with funds to send transaction on the chain. And so this is the abstraction that's made at the front-end part to sign the stuff. So we get the signer from the provider, and then we set the signer in our big shared state. So step 3 is to connect to MetaMask and get accounts. So basically, this is kind of the same idea of provider.get signer, but this is just to render the UI some details about the account. So we get all the accounts inside the MetaMask wallet. Then we just get the account 0, so the first one that is returning through MetaMask. Account 0 being the account the user is currently logged in inside MetaMask. And then you set account to this address. And then when you have everything, we can create a contract instance, which will be the object who will interact and that will abstract this idea of contract on the chain and set this to our state. So then we can reuse this inside other components. And then we check if the owner is the contract owner. Why? Because we have this only owner modifier on the smart contract. And so we will render a different UI based on if you are the owner or not. If you are the owner, you can deposit XRP into the bank and withdraw. If you are not the owner, then you can borrow XRP there. So this is basically allowing you to do some conditional rendering on on the stuff. So what I'm gonna do will be this. Okay, and then if I go back to Brave on this and escape there and go to the port the app is running on. We have the same front end, but normally when we click on connect wallet, we get this. And this is the address I'm currently connected on MetaMask. So we have made this component working, we have injecting the state, and then basically we need to implement the bank balance stuff, the deposit stuff, and all the application.